Hi everyone, this is the paper that you picked up on Friday. So what I want you to do with this is put this aside, put this in your notebook, because I've actually decided to do something different today that I think will help better prepare us for our first unit in this module. So the notes that I'm going to give you are going to be called rational, radical, rational. So go ahead and add these onto a lined piece of paper in your notebook. It is there if you want to print it as well, but just keep in mind, this is just some quick notes to look at, couple practice problems at the end, and an opportunity for extra credit at the very end of the video. All right, so the first thing we're going to be looking at is a rational expression and a radical expression and how to convert one from the other. So if I have something that is rational, it is going to have a base, a number, and then it's going to have an exponent that's a fraction. So I'm going to turn this rational into a radical. Now when I turn it into a radical, we're going to be using this symbol, which many of you know to refer to as a square root. However, it can be any root. Now they call it a square root because there's usually an understood 2 here, but it's not always there. They can put any number there. If they don't put a number there, then we're supposed to know that that number is 2. There's also an exponent, and the exponent, we know it to be 1. If they don't write 1, they're not going to write it unless it's some other number. Okay, so to turn from a rational to a radical, there's a couple of important pieces. The base is whatever number is written first. The exponent has 2 powers. The top number is going to be referred to as the exponent. The bottom number is going to be referred to as the index. Now, when I rewrite this from a radical to a rational, I'm just moving the pieces around to their proper location. And then I can convert it back from a radical to a rational. So I have 2 more literal examples here that we're going to go ahead and work through. So I have x to the power of p over r. So I'm going to start with the radical symbol. I'm going to put the base x underneath, put my exponent out here, and the index r right here. Okay. Now if I want to convert that back into a rational, just going to undo what I did. X p over r. So now if this is so easy to do, why is it necessary? Well, sometimes it's easier to solve from rational form, and sometimes it's easier to solve from radical form. So we need to be able to convert from one form to another. So this next one, y equals the power of a over b. So y, and this time I'm going to put the a underneath, and then b. It does not matter whether the exponent goes inside the radical or outside the radical. So keep in mind, because of mathematical operations, you could do the exponents first or the root first. So just know that they could place it either location. Then we have y back to the power of a over b. Okay, so right now we're going to convert some radicals from rationals to radicals. Rationals have a fraction in the exponent, so I like to think of this word ration right here and think of it kind of like a fraction. Okay, I know it's not the same, but fraction, rational, fractional is just what it reminds me of. So if I take every rational here and I want to write it as a radical, we're not going to simplify right now. I just want to practice writing it. So 25 to the 1/2 power, I may not know. But if I rewrite it as a radical, maybe I will know it. So if I do 25 to the exponent of 1, and then the index of 2, or the root of 2, that is really written like this. Now, if I had given you that and I said, what's the square root of 25? The square is because the index is 2, and the square root of 25 is 5. You guys would know that, but you may not know it from this form here. So sometimes it helps us to rewrite it. Okay, so let's go ahead and rewrite this next one. If I was rewriting this one, the base would be 6, the exponent is 3, and the root is 2. Now I'm going to go ahead and put 2 in this one, but keep in mind, it's not very likely that they're going to put that 2 there, because they expect you to understand that if there's no number there, that number there is 2. Okay, this one here. Our base is the fraction 4 over 5. Now, if you can get the 4 over 5 to fit underneath without the parentheses, you can do that. But if the radical sign only goes over the 4, so if it was to look something like this, that would be a different answer. So we don't want that. Okay. Now, it's always a good idea when you're putting it underneath, just go ahead and keep your fraction with parentheses around it, and that could help us from making that mistake. So then we have for the radical 4/5 to the power of 7 and the root of 8. Now, notice that every time I'm writing that number, I'm writing it inside that little check mark piece. Do not write it out in front, okay? So that's rewriting from a rational to a radical. Now, what about from a radical to a rational? Well, that's just the same thing. So here, I know that the square root of 16 is 4, but we're practicing writing this. So know that the exponent here is 1 and the index is 2. Even if they don't write them, we need to know that. So when we write this in a rational form, that is 16, 1 over 2 for the exponent. This one here, our base is 7, and then our exponent is 4 over 5. This next one, they didn't put parentheses around the fraction. So I'm going to go ahead and add parentheses. That might keep me from making a mistake, so that when I rewrite it, I know the exponent goes with all of this, because 4/9 was what was under the fraction. So I have 4/9 to the power of 1 over 2. Okay, remember the exponent is 1, the index is 2. All right, easy enough on converting from rational to radical or radical to rational. So like I said, why do we do this? Because when we need to evaluate these, sometimes it's easier to see the answer from one form and not so easy from the other form. So I'm going to go ahead and look at these 6 questions and see if I can solve them without converting from one to another. And if I can't, I'm going to go ahead and convert to the other form to see if that helps. Sometimes neither form will help and we will need our calculator, but we'll be talking about that part in class. All right, so here I have 8 to the 2/3. I don't know what 8 to the 2/3 power is, but if I rewrite it in a radical form, I can tell you that the cube root of 8 is 2. So then I have 2 squared, and 2 squared is 4. So what does the cube root of 8 mean? Well, the cube root of 8 means what number times itself 3 times would give me 8. And that would be 2. 2 times 2 is 4. 2 times 2 is 8. So the cube root of 8 would have been 2. Now on this next one, I have 1/8 to the power of 2/3. I don't know what that is, but let me go ahead and try to rewrite it this way. 1/8 to the power of 2 with an index of 3. Okay, now if I'm just looking at this piece, all right, what number times itself 3 times will give me 1? Well, that's 1. What number times itself 3 times will give me 8? That's 2. So the cube root of 1/8 is 1/2. Look at letter A. The cube root of 8 was 2. So the cube root of 1/8 is 1/2. See if you can make a connection there. Then I have a square. So now I'm squaring everything. Just like 2 squared means 2 times 2 is 4. 3 squared is 3 times 3 is 9. 4 squared is 4 times 4 is 16. 1/2 squared is 1/2 times 1/2. That would give me 1/4. Okay? So sometimes turning from a rational into a radical can help us. Here, 27 to the 2/3. I don't know what this one is just in rational form, but I know that it can be easier if I turn it into radical form. So what is the cube root of 27? What number times itself 3 times will give me 27? That will be 3. 3 times 3 is 9, times 3 is 27. And we still have that exponent of 2. So then 3 squared is 9. All right, so what about letter D? This one's in radical form. Now, there are 2 ways to actually do this one, and sometimes there are more than one way. So we've got to look at both of them. let's look at the first option, right? So the first option here, if I want to turn this into rational form, I would have 10 to the 3 over 3 power. That is the same thing as 10 to the first power. That would give me 10, right? So the cube root of 10 to the third power is 10. Now, there's another way, so I want to show you both ways. The second way is, what if I did this part first? What if I didn't convert it into a rational? What if I kept it a radical? So what if I did the cube root and 10 to the third power is 1,000? Now, the cube root of 1,000 is 10. So sometimes it helps to convert it to rational. Sometimes you can solve it directly from rational. Either one will work for you. Okay, so keep that in mind, that there will be more than one way for a lot of these. It's just, do you understand what that way is telling you? Okay, so let's look at this next one. The fourth root of 1/5 to the power of 8. Well, if I know that I don't understand that, I'm going to convert that into a rational. So I'm going to have 1/5 to the power of 8 over 4. Oh, that didn't help a whole lot. I don't know what 1/5 to the 8 over 4 power is, but I do know that 8 over 4 can divide. So 1/5 times 1/5 gives me 1 over 25. Okay? So you got to think outside the box just a little bit. Think about, I may not know the whole thing, but I might know this piece. And if I can simplify that piece, the rest of this could work for me. Okay? All right, so on letter F. First, let's look at it. What if I convert it to a rational? So I would have this 36 to the 3/2 power. And I may not know that. So if I don't know that, I might be like, yeah, that's not going to work. Let's try something else. Okay. So what is the square root of 36? Now remember, there's a little 2 here. Okay, they just don't write it. So what is the square root of 36? Well, the square root of 36 is 6. So then we have 6 to the third power. So 6 to the third power is 216. Okay, so that means that this one must also equal 216. But if we don't know it one way, we can go back, see what we can simplify, and find our second way. Now, like I said, there are 8 examples here for you to try. If you try these 8 examples and upload them by Sunday at 11:59 p.m., that'll be 10 extra credit points. All right, sorry for the delay on the video, and let me know if you have any questions.